So, good afternoon and a warm welcome to our webinar. It's now 3 o'clock Central European time, so it's time for us to kick off this webinar today. This webinar has got the title Open Signaling for Infrastructure Managers. Take control, reduce costs, and eliminate vendor lock-in. This webinar is arranged by Prover. My name is Lars Dahlberg, acting as the moderator. I'm going to do my best to guide you through this webinar this afternoon. So let's take a look at the content of this webinar that we have prepared for you. So we're going to start to talk a bit about the challenges and why signaling system costs more every year. That's really one of the main reasons behind this initiative. And then what is open signaling? What is it really all about? We're going to do a brief of that, but it's not going to be like a very technical overview. So it's going to be easy to follow and understand. Then we're going to move on and talk more about the business case for open signaling, talk about cost savings, how you get better control, and the long-term value from these types of initiatives related to open signaling. And of course, move over and talk more about how to get started, some practical steps that infrastructure managers can take to take advantage of open signaling, cover some of the obstacles, and then end with a Q&A. And as usual, you can use the private chat functionality in Webinar Geek to ask your questions whenever you want. We're going to answer the questions in the end of the webinar. And the rest of the participants will not be able to see your questions. But of course, I will do that, and also our speaker, which is really a subject matter expert in open signaling. So let's introduce today's speaker, Mr. Jesper Karlström, CEO from Prover. Welcome, Jesper.
Thank you, Lars. Yes, exactly. I will talk about open signaling today, and as you said, Lars, it will be deliberately non-technical. So the purpose is to give some understanding for if you are a manager or decision maker on why open signaling is important for infrastructure managers.
Yes, so I'll hand this over to you, and I'll be back later.
Thank you, Lars. When I explained this to some politician that I talked to, he actually gave me some food for thought back. He pointed at the hotel on the other side of the street and said, imagine that we would be building this hotel, and then we need to invest millions, but in the contract it says there will be 40 years of exclusive support from the one single vendor, the one that built the hotel. Then no other company may touch the plumbing, wiring, or elevators or anything in this hotel during this time. And after 40 years, the contract will not be renewed, so you must tear down this building and start all over. That's kind of an absurd picture, but showed me that he had understood my message, at least, and no one would accept this for a hotel. So why do we accept it really for signaling systems? This is the main question in today's webinar. I will talk about the problems we have in this domain, but also one way of overcoming those problems. So because this is supposed to be non-technical, I'd like to start by briefly explaining what rail and metro signaling is about. A signaling system is the one that controls switches, signals, and train movements to ensure safe operations. So they are the traffic management safety barriers, you could say. There could be lots of smart functions in the traffic management systems involving automatic timetable operation and so on. But in the end, you want to have a safety critical system that checks that you don't move switches under trains and you don't clear signals in ways that allow collisions between trains. So the safety barrier is called a signaling system. And this is the one we will discuss today. And these are the ones that are very expensive today. There are growing demands in this domain because cities are growing, and when they grow, they require more from the public transport system. So more capacity, but also change travel patterns. So for example, if you build a new suburb or a new bridge, then people will travel in a different way, and that might put some stress on some of the stations. You might want a new track or a new switch somewhere. So you need to constantly maintain and change the system. Too often then, infrastructure managers, they cannot make the necessary updates because the system might be under a long-term maintenance agreements with one single supplier. And that supplier then is the only one that can make a change to the system, and they will normally give you an offer saying we can make the change you want and it will cost like this. So the infrastructure manager needs to choose either accept the offer or decline. But if the infrastructure manager declines, then there will be no competition. No one else can do it. It's just no. And you need to move on and maybe buy some more buses instead or whatever. Solve the problem in a different way. Also, the know-how within the infrastructure manager staff might be weak because there has been a tendency to let the infrastructure manager become smaller and smaller organizations. So you put all the expertise outside in various companies, and the organization itself is only supposed to buy stuff. Therefore, also the infrastructure manager becomes weak in relation to the suppliers. When systems are aging, they also become difficult to maintain for various reasons. It could be that there are lacking spare parts, but it could also be that there is lacking expertise. For example, if you have systems that are built on relays, the way signaling systems were built back in the days, then you might have difficulty finding engineers, young engineers that can understand and maintain such systems and change them. So this is usually a driving factor for replacing relay-based systems with computer-based systems, that there are lacking spare parts and lacking expertise. I summarized the 4 main challenges for aging signaling systems like this. We have rising maintenance costs. They become more and more expensive to maintain. That's usually because the spare parts are only produced to allow maintenance of those old systems, and the fewer they become in the world, the more rare, the smaller market for those spare parts. So they need to increase their price, and also expertise become more expensive when they become a tight resource. Connected to this, of course, is that eventually spare parts will disappear. You will not even find them because manufacturers, they discontinue components that are rarely used, and that makes replacements really difficult. And with the shrinking expertise, the main explanation for that is that it's usually older people that know how older systems, what they require, and they leave the domain or they retire. So they are fewer and fewer over the years. And at the same time, then, the demands are growing. So every change requires deep understanding of how the system is designed, and also some knowledge about how you can build a safe system and argue that it's safe and have it approved by safety authorities and so on. If you then choose to buy a new system, you need to maintain it over a long time. You don't only want to buy it and then a couple of years later on it stops functioning. So you need to ensure some maintenance. And there are basically 2 options. The traditional one, option A here, has been to have a long-term agreement with the supplier. So you have a single vendor, and which was the supplier of the system, and they will guarantee spare parts and support for some long time. It can be 25 years sometimes, but it can also be up to 40 years. The advantage, of course, for the infrastructure manager is that now the lifetime is guaranteed for the system. There is a contract and there is someone that will take responsibility. So that's why these contracts are entered. But also, it can be very high cost over the lifetime because of reasons I explained earlier, that those suppliers, they can dictate their prices because there is no other supplier that can compete. So you become totally locked in with the supplier. And also, when the maintenance contract ends after 25 to 40 years, it's not unusual that the supplier says, well, this technology is old now, we don't maintain this, we have a new, much better system that you can have instead. But to install this, we need to make some substantial changes, maybe even locking down some lines for a few weeks or even months and replace the existing system with something new. And then you start all over. This is also very disturbing for infrastructure managers and in particular for passengers in the end. We call that a big bang replacement because you do everything at the same time. The other option then, option B, is to just trust the market. So you don't enter long-term agreements. You can have support and maintenance agreements that are 5 years or 10 years. And then you make a public tender for a new support and maintenance contract. Then there will be some competition. You can then replace, in order to do this, if you want to open up for competition, you need to use standard components and you need to follow standards and you need to have standard communication between components. The reason for that, of course, is that if an open market should be able to compete and offer their expertise, it needs to be open technology so that the engineering firms can know what they need to do and can make an offer. On the other hand, when we have those, when we build with standard components, with clear interfaces and so on, then we also reach some benefits. So, for example, you can replace components without redesigning the whole system because it's a standard component and you can find a replacement for it from a different vendor. At every moment, or at least every time you make a new public tender for a support contract, you can choose your best supplier and you will have the ownership and control over this. You don't leave this to some other supplier. This also enables you to evolve the system slowly because you can say, I want a small change, I want a new track at this station, or I want a new switch somewhere, or I want to move a signal. And this will enable your market to compete and give you an offer. Every consultancy firm or engineer firm can give you an offer and you choose which one you take. This idea of building using standard components, to illustrate that a little bit, I'd like to answer what's the point of a standard. If you take something that I think is familiar from your life, if you need to change, suddenly the light is out somewhere and you need to change to a new light source. You don't need to figure out which was the supplier of the original lamp, and you don't need to call that supplier and find a new lamp or a new light bulb. You can simply go to your store and there will be a large supply of light sources with the E27 socket. That's the name of the standard that we all know. You can choose between them and you can go home and you can install this and it will work. The reason it works is that there is a well-defined standard called E27. It tells exactly what is required from the interface, and then there is an open market supplying components, in this case a light source, but it could be anything. So this solves the problem that when you invest in a lighting system at home, you are not forced to buy light bulbs from the system supplier for the rest of your life. You trust that if some supplier of light sources is out of business, then there will be another one that can supply you with light sources. And now try to just translate this to the realm of rail and metro signaling, and you can understand the vision we have. This to moving in this direction, that has been done already in another domain, the domain of mobile communication, telecom. So if we go back 20 years or maybe a little bit more, then we were essentially there in the telecom business where we are in the rail and metro signaling now. Every mobile operator, they built their own network. They had their own solutions, and if you bought an antenna from someone, then you had to have the router from the same supplier and so on. Then the domain worked a lot of standards, and in the end, the operators could buy from multiple vendors. There was competition that drove down costs and accelerated innovation in this field. And any handset works on any network. So if you talk in your mobile phone and you move through your city, you will not notice when it's a handover from a Huawei mast to an Ericsson mast, for example. That will work seamlessly because there are standards, and it's well understood now how to mix and match components from different vendors. In rail signaling, we're still where telecom was 20 years ago. And what we aim to do with the Open Signaling initiative is to enable this transformation that the mobile communication domain made some 20 years ago. Now, before we continue with looking into open signaling, we are a bit curious about our audience here.
Yes, Jesper, we are. So we would like to engage the audience a little bit with the poll. And soon I'm going to press a button here, and it will open up a poll on the screen, and you can easily fill in different alternatives for the questions that we have on the screen. So the question we're asking you is sort of, what do you recognize from your own situation? And some of you might not represent an infrastructure manager. So if you're not, answer as the one you work for. And you can select one or several options of the ones presented below. And the options will be in the poll. We have aging relay or proprietary systems that need replacing. We are concerned about vendor lock-in and rising costs. We want to strengthen our ownership and control. And we have capable engineering partners with signaling expertise. So with that, I'm going to open up the poll, and you can select several of these four when you answer on the poll. It's going to be so interesting to see the results. So let's start and see if we can get some interaction going. Now we're getting the results. It took a little time. So great work. Please fill in your answers for these four alternatives. What do you recognize from your own situation? It's going to be interesting to see how this is going to develop.
Quite a few are answering. That's interesting.
Okay. Yeah, we're still getting some answers. It's we have one of them is a contender for winning.
For sure.
Okay, so
now we have the results. We can bring them up and I comment on them a bit.
Yeah, let's end the interaction. Thanks for all your contribution, and you're going to see the results now, and we'll comment on the results. So let's end the interaction, and we'll show you the results. So now you can see the results. What do you say, Jesper? What's your comment on this?
First of all, it's interesting that about half say that we have aging relay or proprietary systems that need replacing. This has been higher when we made more technically oriented webinars on the same topic. So maybe those webinars attracted engineers that had exactly this problem. And now we have a slightly different audience. It's interesting. It's about half that recognize this. The second, though, we are concerned about vendor lock-in and rising costs. It's high here, I would say, maybe more than previous webinars. which might reflect again a change of audience. Now, maybe this time more decision makers having this problem already with vendor lock-in, and how do we escape this somehow? Fourth, we want to strengthen our ownership and control. This is slightly below half, and this is actually I'm used to this not being consensus. Some really want to strengthen their ownership and control among infrastructure managers. Some really like that they don't do so much. They decide what they need, but then they leave to the market to supply them with something that they need. And they don't want to decide over details. So this is of course related to the open signaling attitude, that if you want to do that, then you also you gain control and ownership, but also maybe it's necessary to want to have ownership and control to actually have the benefits. And the fourth here, we have capable engineering partners with signaling expertise. That's pretty low, I would say, this time compared to earlier. Not sure if partners has been interpreted maybe as there are already signed contracts. Maybe that's a weak thing with the question. What we really wanted to know is if there is already a tradition or some engineering firms in the area of the infrastructure managers that normally supply engineering expertise and engineering work. Yeah. So this is a little bit up for interpretation, I think.
Yeah, it's interesting. I hope you also appreciated to get this the results of this little research poll. So with that, I think we just move on and continue with the content of the webinar. I'll hide the results. Yep.
Yes, please do. Okay, so I will continue now with explaining what open signaling is and what we have found to be the most important aspects of it. I mentioned briefly that the purpose of being open is that you want to open up for a bigger market. So you want to have competition everywhere, and being able to replace one part of the system without starting all over with the safety evidence and so on for the whole system. So we have isolated 3 aspects that are important. Open interfaces is the first. So you use open protocols so that components from different vendors work together. This means that whenever you have a communication between systems, subsystems of your big signaling system, that communication should be made in a standard way, so that you don't lock yourself in. If you have 2 components that communicate in some strange or unfamiliar way, then you cannot replace one of them without replacing the other one, because you will not find a new component that uses the same protocol as before. So open interface is important. And I should mention that there is a big and important initiative in the European Union called the ULinks initiative. I don't talk about that today, but it aims to solve exactly this. So open interfaces between signaling systems. If you have 2 signaling systems that communicate, it's supposed to be defined in this standard, or it is defined. And then also, if you communicate with special equipment such as signals or switches, then also that communication is defined. So the open interfaces ambition exists within the ULinks, and I would say it's on a good path. It's gaining attraction, and it's now dominant in Europe. It's not perfect, it's still evolving, still improving, but I think there is consensus that we need this standard, and it will become something good in the end, I'm sure. The second one is connected. It's loosely coupled components. That means that when you build a system based on subsystems or based on components, you don't want them to be the dependency between them to be too entangled, because you want to be able to replace one component without replacing the rest. That's called loose coupling. So they work together, but they are not tied hard together. They are loosely tied together in the sense that you can remove one and put in something else without the whole system breaking. And finally, COTS hardware. COTS is short for commercial off the shelf, meaning that you can buy it off the shelf as in an ordinary store. You just go somewhere and buy it. In practice, it's not literally off the shelf. You order it and you have it shipped to you. But the important aspect is it's not supposed to be purpose-built for you. It's supposed to be something that's available and that you can buy. In particular, also, you want it to follow some standards so that it works well together with the open interfaces and loosely coupled components. But the third bullet is more commercially oriented, that it's supposed to be available as is, even before you order. If you want to understand the business aspects, we need to work on the business case for you. I cannot give any figures because it depends a lot on your precise condition that you have. But if you work on the business case, I would say that there are 4 aspects that you need to focus on. The first one is this will surely lower life cycle costs because of competitive procurement at every stage. So there will be no lock-in. And also off-the-shelf hardware costs a fraction of proprietary equipment, simply because off-the-shelf hardware is used by many. So the development cost is lower for off-the-shelf hardware if you divide it by the number of customers. So it becomes cheaper in the end. That's a life cycle cost aspect. Then you also need to weigh in that this gives you full ownership and control. So you own and understand your system, and when you need to update and improve the system, then you can decide to do that, not your vendor. This is relevant for this business case because you know that you will somehow, as an infrastructure manager, you will now and then have to update your system. So if you know that you can do it, then you have your costs under control. If you don't know that it will be possible, then you might need to take really costly alternative paths to solve your changing travel patterns. The most maybe already covered in the lower lifecycle cost bullet, but it deserves to be stressed, no vendor lock-in. So components can be replaced by another supplier, and you are not dependent on a single company. That's the main advantage. And then that you can do incremental modernization. So if you identify a bottleneck in your metro system, for example, or if you understand that you can increase safety by one small change somewhere, then you can make this upgrade without having to have an extra order to your supplier. You can just open up the public tender to upgrade one station, for example, or to swap one component. You don't need to have those big bang replacements. That also saves costs and headache. What you do need, though, is an ecosystem. So I think it's unrealistic that infrastructure managers today would do everything themselves here. As an infrastructure manager, you should view yourself as in the middle of an ecosystem where you have the hardware supplier, you have a software supplier, and if you don't want to take on the role of system integrator yourself, you need also a system integrator in your ecosystem. Then there is also an important aspect of safety engineering, because when we work in this signaling domain, safety engineering is very important in systems design. So you need also to have experienced safety engineers in your network. There will usually be a large ecosystem here, so you can make a public tender and you can set up a project organization by hardware suppliers, software suppliers, system integrators and safety engineers, and also other roles such as reviewers or assessors or whatever you need. And then you need to set up project organization for that particular project, and the system integrator will take responsibility for driving this project and handing it over to you as an infrastructure manager. Then you, as an infrastructure manager, will need to maintain the system. So meaning saving all documentation on your side and be prepared to hand over this documentation to someone when it's time to maintain the system. It's therefore ideal mostly for small or mid-scale projects. So for example, maybe the best kind of project is if you already have a line, or a metro line, and you want to just change one of the stations, then it's perfect to drive it like this. If you want to build a completely new line with super high capacity and so on, then maybe go with one of the big suppliers and buy a ready-made system. You will have the drawbacks, but also as an organization, maybe this is necessary in some cases because you don't have the bandwidth to handle really big projects. But again, if you build a completely new line and you need a signaling system for that one, it might be worth requiring in the tendering process that whoever wins this tender builds everything with open standards, open interfaces, loosely coupled components, and COTS hardware, so that you know that you can take over and maintain this system in the future. Some obstacles then, based on experience, what we hear. One is we don't know really what it requires to build a signaling system. So I would advise to make a pilot project to prove that it works with minimal risk, and so that you can learn from this pilot project what you need to do. Then you can scale and do bigger projects when you have done it once. Another thing is that safety proving is too demanding. It's in the rail and metro signaling domain, safety proving is really difficult in the sense that there are high standards for what you need to do, and you will usually have to have your safety case approved by some transportation authority in the end, and they require that you know what you're doing. There is, though, some guidance. There is this Senelec safety standards. They are demanding, but they are also well known in the domain. So there are many that can deliver projects according to Senelec and know exactly what is required. That's well known among engineering firms, how to do that. So even if you don't have the capacity yourself as an infrastructure manager, you will find suppliers that can do that for you. That also is the answer to the next question. We don't have the internal competence. You don't need to have it internally. You need to build an ecosystem of specialized partners around you and have a market so that you know that there will be engineering firms that will come back to you and make new offers whenever you have a need for an upgrade. The fourth one, we hear sometimes that our procurement rules don't fit. So they have some infrastructure managers have the guidelines that when they buy something, they should only explain the needs. They should not tell exactly how the system is to be constructed. So they can't really say it needs to be open and so on. I think, though, that it makes perfect sense to not only think about passengers here, saying we need something that can move 50,000 passengers from this station to this station. It's also, we need something that can be maintained. It's something that many can maintain and so on. So it's not wrong to require in the public tender that we need open specifications, we need open standards, we need loose coupling and so on, because it will give you more bidders, it will foster some competition, and the outcome will be fairer and better. and in the end you will be able to maintain this system. Okay, this is not only thinking. We see already that this is happening. So there are some open signaling systems that are pilots ongoing, and we are about to deploy a few. We also see that some public tenders, they actually require things that would be in the direction of open signaling, such as COTS hardware or EU-LINX standards and so on. The second bullet is really important. So we have now standard industrial hardware that meets the highest safety requirements, called SIL4 in the Senelec standardization organization. SIL4 is a safety standard that is required for rail and metro in Europe. So it's a really high safety standard. The problem with the COTS market before was that there was essentially only one supplier that could live up to the requirements of SIL4. And when there is only one supplier, then it's automatically a lock-in. So even if you would go with COTS hardware, you couldn't swap this COTS hardware for another supplier. You were stuck with this supplier. Good supplier, but still stuck. What has happened the last years is that a few more has emerged. So we have now at least 3 European suppliers that can supply industrial hardware that meets the Senelec SIL4 requirements, and that opens up for competition, and that makes this really open in the end. So it has suddenly become a possible alternative. It wasn't just a few years ago. Open standards, again, is what enable that you can change vendor in your systems. And the possibility to engage different vendors in different projects is what enables the infrastructure manager to have real ownership and control. If you want to know more about this, you should look at the opensignaling.org website. I will bring it up in the end of this presentation, so you don't need to take a note now. We will also send out some information that you can follow up on if you're interested. We currently have 2 ongoing projects. So one is a pilot in the Stockholm Metro, where an old relay-based interlocking is currently being replaced by an open computer-based solution to try this concept and see if it's something for the future. We also have a depot outside Paris. It's a much larger project in the sense that the number of switches and so on is huge. It's pretty different because it's brand new. So everything, including the buildings and tracks and everything is built now. And at the same time, there's ongoing software development and so on, together with the construction of drawings and signals and infrastructure, everything. Both those are real open signaling projects that we are involved in, but also with partners. So what we hope to see is that the market would transition from a closed market to a more open ecosystem. So if we summarize here what we had and what we aim for, so yesterday we had those few large vendor control the entire value chain with proprietary hardware, software, and interfaces, where infrastructure managers have limited choice, and you can't really change a vendor without replacing everything. What we want to achieve with the open way of thinking is to have to use those industrial computers that are now good enough for rail applications, to apply open standards so that we can mix and match components from different vendors, and enable engineering firms to maintain the systems, with the aim, of course, that infrastructure managers regain ownership again. If you want to try this out and are curious about open signaling, then I would advise you to identify a pilot station somewhere, something small, preferably, where, for example, like in the Stockholm Metro case, you have some aging relays and you need to replace it, and you take the chance to do this with open signaling. Then you engage engineering firms and hardware vendors and safety assessors and so on as an ecosystem. You build a project organization for this. You need to give them, this project organization, clear requirements. So you need to tell them exactly what they are supposed to deliver. And of course, they need to meet the same safety standards as any signaling project. So this is not a way of lowering your ambition. It needs to be the same. I'm just claiming that it's possible to construct a project organization like this because there is lots of skills out there how to build this. And then invite multiple suppliers. If your specifications are open and easy to read, then you don't need to stick to a few suppliers. You can have an open tender and invite to this project or to future projects. Then you run this project and you learn from it, you build competence, you build your ecosystem, and then it's ready to scale. I don't know what you in the audience have, you answered a little bit in the poll before what situation you have, but we can also talk through your specific situation if you're interested. So, for example, in a personal meeting, if you are interested in discussing this in a personal meeting, then you just reply to our follow-up email after this webinar, and we'll set up a time for you. Right, that was the end of my slides, but we planned also for having some questions and answers.
That's correct, Jesper. And we have received some questions while we've been going through the content of the webinar. So we're going to start with them. And then, of course, you can still type in your questions using the private chat functionality in Webinar Geek, and we'll do our best to answer. And we have another, at least 15 minutes here. So I hope we'll be able to cover all the questions. And if we don't, we will provide you with answers after the webinar. So I'll pick one of them here. So this one, with the digitalization of signaling systems through CBTC and ETCS, how does Prover believe that the new systems can contribute to open signaling and ensure interoperability between suppliers?
Right. This is so far we have not focused on the main systems for ETCS. And sorry for being a bit technical now, but I need to be that to answer questions like this. So maybe because of the audience, I should briefly explain what this is about. ETCS, as was mentioned, that is the standard for train control systems in Europe. The standard that is followed right now that would enable interoperability in the sense that the goal is that you should be able to drive a train from northern Sweden to southern Italy, and the signaling systems would be compatible along the way. And when CBTC was mentioned, that is you can think of it as a counterpart for metro rather than rail. It's not exactly the same, but in this context, I would say it is. So those systems are typically very advanced, and what we have focused on so far is cases where it's not a demand to be compatible with ETCS or CBTC. So it's simpler systems that don't need those things. And I think for some time that the main target of open signaling will be simpler systems like that, because also there are good systems available for ETCS or CBTC, while infrastructure managers usually have more special requirements to be compatible with their legacy systems and so on, where it's really good to work with open signaling systems. That being said, also in ETCS and CBTC, we have initiatives like ULinks, used a lot for mainline, so maybe mostly for ETCS, of communication. So that is open interfaces in communication, so along the lines of open signaling. We also have some smaller subsystems, such as level crossings, for example, where it is indeed possible to build with open signaling principles, COTS hardware, and so on, and still have it communicating with the more advanced ETCS systems. So to summarize, maybe this was a little bit blurry, but the summary is that we have tried it only on secondary lines or at least more conventional signaling. So I can't answer how it would work in the more modern kinds of signaling systems, but we see that there are components in the more modern ones where this can definitely be applied.
Okay, thanks, Jesper. A couple of people also asked if they're going to be able to get the recording, and you will. So tomorrow we will send out an email with contact information and or a link to the recorded version that you can look at or distribute to others. So that will be sent out tomorrow. But let's move on to another question, and this is an interesting one. How is the open signaling approach intended to address the EU Cyber Resilience Act, with multiple vendors able to modify the system who takes on the manufacturer's responsibility under the CRA, for example, vulnerability handling and security updates over the product lifecycle? So it's an interesting question.
Yeah, that's also really a nightmare. So I don't know how much you know about the European Resilience Act, but to put it simple, it's about cybersecurity and it's about guaranteeing that there can be no attacks against signaling systems. In some cases, it has been solved by simply not connecting the signaling system to any network externally. So there are cases where the signaling system is only connected via copper wires. That's one way of simplifying the argument. Every piece of component will soon have to be compliant with the European Cyber Resilience Act, meaning that everyone who supplies will need to make some tests and guarantees about their own equipment. Maybe the most difficult aspect here is to guarantee that the maintenance guidelines are good enough, because when some maintenance staff come there, they will need to, for example, be able to upload a new program. So they will have to connect to the system somehow, and you need to have some measures to ensure that there cannot be any bad code injected, for example, or things like this. It's not easy. But it's doable, and it's the same regardless if it's open signaling or any kind of signaling system. What is an advantage maybe for to buy from an existing supplier is that they take the full responsibility of the cyber security aspects. That is, I admit that is an advantage for buying from a big supplier like that.
Okay, so let's move on. We have another interesting question here. Has there been any data on how the open requirement specifications affect the price of the tenders?
I don't have any data really, and that's sad, because it would be really nice to have any data. So far, the data has mostly been observations about certain situations where it became unreasonably expensive in the traditional way. And everyone involved thought that this wouldn't have to be this expensive. You can also, if you are an infrastructure manager, you can probably compare, if you have, for example, one line where it's a proprietary or a vendor lock-in situation, you compare the maintenance of that with what you have to do with another line. Maybe you have an older line, where there are relay-based interlockings. You can compare yourself. What are the costs you have when you want to make a change in a relay-based interlocking, where you go to the open market and say, can you make this change for me? Compare that cost with the cost to make a change in a system where you have vendor lock-in, and you will be able to answer yourself what the difference is, I would say. But it varies a bit over the world what the effects are.
Okay, Another question. What's the difference between EU links and open signaling?
Both have the same vision, but EULynx has focused on communication between subsystems. And that's I wouldn't say it's a difference. Open signaling EULynx is one open aspect, and we just want to do more of the same. So not only the interfaces, we also want to have components in the signaling systems we want to be able to replace them. So when EULynx focused on communication from the signaling system to from the main computer, so to speak, to signals and switches and also to other computers, we want to build with smaller parts that we set up with loose coupling. That's the main difference. So the philosophy is the same.
Okay, we also have some comments. Very nice to hear that it's already happening. So, not a question really, but nice comments. So thanks. All right, another question. What to do if the infrastructure manager is already in vendor lock-in? How to start migration to open source software? Is your proposed minimum viable approach the best to start in an aging or small station to follow? Yeah, that's an interesting one. So maybe it needs some
Interesting
clarification.
one. If you're already locked into a long contract, then I'm not sure there is much to do until this contract expires on that particular line. But if you, for example, discuss prolonging the line and you want to build one more station, say, in the end of the line, then you can, of course, discuss with that vendor if they want to include this station in their system and what the cost would be. And otherwise, an option would be that they provide an interface and they open up. So they need to specify then how to communicate with their system. And then you build an open system for the new end station and you set up a communication. And then I would surely recommend using EULynx or some other standard communication.
Yeah, so let's take another one. What are emerging areas like China, India, and Africa doing related to open standards or similar closed source path that the old Europe followed?
Good question. I'm not so. I know a little bit. I would say that India seems to be well positioned because they have a history of smaller systems. Usually, they buy like COTS, but they have bought from one of the big suppliers, but they don't buy whole systems. They buy something smaller and they build things themselves. So taking the step for them from those rail-specific small computers to more industrial standard computers would be a small step, and I think they have also the skills and so on. Africa, I know nothing about, honestly. China, they have really skilled suppliers. My impression is that when they create new systems within China, they like to stick to traditions and do them in the same way as they have been done for a long time because it's easier to argue. But also that Chinese suppliers, when they want to offer something abroad, then they are more open to change ways and to try new ways of doing things. But this is only based on my experience, and it's not. So I have been working mostly in Europe.
Okay, another interesting one comes up here. Is open signaling here about modular black box components with open interfaces, or about fully transparent systems where the IM, the infrastructure manager, owns the logic?
Yeah. So I would say in some hardware, if you think of hardware, you need it's an advantage if you can go down in size, but I think you come to a point where you have now you have your industrial computer here, and it doesn't make sense to require that every component within this computer can be replaced. The importance is that you come down to a point where you can say, okay, if this industrial computer breaks, then I will be able to find another one to put in its place. Then you have a good modularity. Then we also have the software aspect, and I think it makes sense to say that the infrastructure manager should own the logic. So they should know exactly what logic is run on the platform, because it's important to also be able to maintain or to change the logic. And they cannot be sure that it will be the same software supplier in the end that will do it. So they need to own it.
Okay. All right. So a lot of questions, and we'll do our best, see if we manage to answer everything here. If not, we will come back with answers after the webinar. The system will save your questions. So, let's take another one. How would you manage the safety case of the system? Would you specify an output set of requirements for components that can be interchanged? These could be used to manage the interface.
Right. So there is one norm. There is a European norm 5129 that dictates sometimes pretty strongly how you need to do this. So you can't really come up with anything here. You need to follow this standard. So its main idea, I would say, is that you have a systems approach to safety, and then you have this idea that when you allocate safety requirements to subsystems, and then every subsystem needs to be well documented, and one strict requirement is that the subsystem has what is called a safety-related application condition. So it needs to document under which condition it is safe to apply this subsystem. So if you cut your system in small parts with loosely coupled components, then every component needs to have an SRAC, as it's called, safety-related application conditions. If you now replace this component with a different component, then you need to compare the safety-related application conditions for the new component with the old one. And if you have some new conditions for the new one, then you need to do some safety work and update the safety case. Check that those conditions are indeed fulfilled and so on for the safe application of the component. So it becomes, you do have some work to do on the system level, and that makes sense, because in the end you want to ensure that the system you build is still safe even if you swap out one component. In the best of worlds, in the future, maybe it's so standardized that you can just say this component fulfills this IEC standard or whatever, and then you just put it in and you start running. This is not how it works now. You always need to look at the SRAC for this component and do some safety engineering around it. I hope that answered the question. I'm not sure.
Yeah, so it's almost 4 o'clock now, but we have one more question, I think, that we can try to answer before we have to close down the webinar. Are major signaling suppliers such as Siemens, Thales, and Alstom embracing the concept of open signaling? What do you say, Jesper?
I would say that they definitely embrace U-links. Maybe they weren't when it started, because it was also unclear if it would be embraced, and there's no point of being the first in opening up your system. You just expose yourself to competition, and the standard might not be good enough to allow some serious development work and so on. Then Norway had a tender for a signaling system in the whole of Norway, and they required U-links from the supplier, and that created some interest from all of the suppliers, and Siemens, Thales, and Alstom were all among, I think, the bidders there. Siemens won that in the end. And this has then repeated in different countries. So I think that the big suppliers, they definitely understand that they will have to be ULinks compliant in the future. I haven't presented the idea of open signaling to them, and I haven't hoped that they would embrace it when it comes to cutting systems in smaller pieces. I mean, they already have something that works. So if I were them, I wouldn't embrace open signaling too much. But I don't think it's necessarily a bad thing for them either in the long run. If you look at what happened in the mobile communication domain, it wasn't bad for the domain. It was actually pretty good, because when it becomes more viable to order more systems, then the market grows. So I think if open signaling is attractive for the end customers, then it's in the end also attractive for the suppliers.
Yes, it's 4 o'clock now, and do you have one more slide, Jesper, that we would like to show before we close down the webinar, or is this the last one?
Yes, just
Yeah,
I
exactly.
promised
Here we have the
to
address for
show again the
opensignaling.org. Exactly. So you can
and
see
I
now on the
think
slide,
we will also send out,
opensignaling.org.
yeah, and we will send out some information this webinar, so we can include this link, I hope.
Yes.
Is
Yes,
that
we will.
true, Lars?
So thanks, and with that, we'll conclude and close down the webinar, and check your mailboxes tomorrow. You will get the email with the recorded version, the contact information, and links to opensignaling.org. So thanks, and we'll close down the webinar for now.
Bye-bye.
Bye-bye.